Okay, this is lesson 6-2. So in 6-1 we learned how to solve a system of equations by using graphing. And today we're going to learn how to solve a system of equations by using substitution. Sometimes with graphing you can't get an accurate answer, but with substitution you're actually going to be doing mathematical equations and you'll get much closer to an accurate answer. So that's why you want to have this way of doing it as well. Alright, so you have a vocabulary word of substitution, right? And the example they've given us is from the movies today, the real life example. We have a movie A that earned $31 million the first week but fell to $15 million the following week. Movie B earned $21 million the first week and fell to $11 million the second week. So at what point will the movies earn the same amount of money is basically the question. So today we're going to use a movie theme for going through our lesson, I guess. Oh yeah, here we go. So, there, let me slide that down. Substitution is a method to find an exact solution of a system equation. There's your definition. And one method to find an exact solution to a system of equations. And actually we're going to learn several methods, but in this one we'll solve for y in one equation and substitute in the value of that for the other. But let's talk about it a little more specifically. So step one in solving using substitution, you're going to solve at least one of the equations for one variable. Alright, so we're going to have two equations again like we did in the last thing, and one of those equations you're going to fix it so that one of them is being solved for one variable. Or it might be x equals 2y minus 10. Alright, one of them you'll manipulate it so it's just solved for one. And then you'll substitute. And we'll look at this more specifically. So the second step is you're going to substitute your result of this and, oops, sorry, my bad. Let me get my little highlighter going again. You're going to substitute one of those values for x in the other equation. So that's step two. You substitute the result from step one into the other equation. And then you'll solve that equation and you'll get a value for either x or y, whatever variable you're solving for. And then step three, you'll take that value from step two and put it into your other equation. So let's look and see exactly what that means in a real life situation. Okay, here we have y equals 2x plus 1, and we have 3x plus y equals, we have y equals 2x plus 1 and 3x plus y equals negative 9. So you'll notice step one's already done. One equation is already solved for one, so we don't have to do step one. Step two says to substitute 2x plus 1 in for y in the second equation. So see what this, so here we have y equals this, right? So in 3x plus y equals negative 9, we can substitute 2x plus 1 because we know that y equals that. Okay, let me say that again. We know from our first equation that y equals this 2x plus 1. So when we find y in our second equation, we can put that in place of the y. So we'll put 3x plus, and so instead of writing y, we're going to write 2x plus 1 equals negative 9. So 3x plus 2x is 5x plus 1 equals negative 9, minus 1 on both sides. 5x equals negative 10. Oops, sorry about that. Negative 10. And we find out that x equals negative 2. Okay, so now we know that x is negative 2, and we have to figure out what y is. So that's what we do next. So that's step number 3, is we're going to take our negative 2 and substitute it in. So and we can use either equation, but I'm going to use the y equals 2x plus 1. Well, now I know that x is negative 2, so I can say y equals 2 times negative 2 plus 1 and solve for y. Y equals negative 4 plus 1, y equals negative 3. So our y value is negative 3, negative 2 comma negative 3. And we can check it by graphing. So let's graph these two guys. Let's see if I can slide you over a bit. Okay, thank you. So we have 2x plus 1. So 1, oops. I don't know why that did that, but let's get rid of it. Let's try it again. Okay, so we have 1 and up 2 over 1, up 2 over 1. Something that looks like this. And then we have y equals negative 3x minus 9, right? To graph it. So we're here at negative 9, and we go up 3 over 1, up 3 over 1, up 3 over 1. And it graphs something like this, and we see that the intersection is negative 2 comma negative 3. Okay. Okay, here's your guided practice. You have two systems of equations to solve. So by using substitution, and then you can check it by graphing. If a variable is not isolated in one of the equations, like if you had 2x plus 7 equals 14, and, not plus 7, excuse me, 2x plus y equals 14, and you had negative 3x plus y equals 10, you would have to first change it so you're solving for just one variable. So you'd have to turn one of these around, plus 3x plus 3x. And you'd have to do that step first, so you had 3x plus 10. Now you had a variable isolated that you could take and substitute in to your other equation. So make sure one of your equations is solved for one variable. It can be x or it can be y. Also, think about this. If you have two equations and they're already in y equals mx plus b form, then you can just put them equal to each other. Watch what I mean. Say you have y equals 2x plus 1, and you have y equals 5x minus 10. Okay? So if I have a and it's equal to b, right? A is equal to b, and then I have a is equal to c, then then b must equal c, right? Wouldn't you agree? And let's think about that. So if I have y here is equal to 2x plus 1, and I also say y is equal to 5x minus 10, then these two must be equal to each other. In other words, 2x plus 1 must equal 5x plus minus 10. Okay? So then you can just solve for x, right? And get 2x. So then minus 2x on both sides. And we get 1 equals 3x minus 10. And then add 10 to both sides.
I need the sudden advisory
and so on.
ASAP if you plan on going to lunch.
So that's just a thought that's something you can think about. Please ignore Coach Sutton. And Miss Seymour. Okay, just bear with me a minute. We're going to let these guys finish, and then I'll continue this lesson. Stay with me. We'll get these announcements over with, and I'm going to finish this recording. Okay, that might be it. Okay, now let's try solving by substitution, okay? So we have x plus 2y equals 6, and we have 3x minus 4y equals 28. So the first step is we're going to, it looks to me like we're going to take this one here because we're going to put x, we're going to put it equal to x. And why are we going to do that? Because x has a coefficient of 1, so that makes it the easiest one to isolate. So let's isolate x plus 2y equals 6. And if I subtract 2y from both sides, I get x equals negative 2y plus 6. Okay? Now, I can take the negative 2y plus 6, which equals x, and substitute it into the second equation. So I have 3x minus 4y equals 28. And I'm going to substitute in negative 2y plus 6 for x. So 3 times negative 2y plus 6 minus 4y equals 28. Does everybody see what I did? I took the value of this x, which was this, and substituted it for this x. All right, so then we solve for that, and we get negative 6y plus 18 minus 4y equals 28. And we add these two guys together, and we get negative 10y plus 18 equals 28. Subtract 18 from both sides, and we get negative 10y equals 10. Divide by negative 10, and we find out that y equals negative 1.
Hunter Rice and Robbie Goodman, please report to the foyer and Coach Sutton.
Okay, then we need to, so we know y is negative 1, right? Excuse me. Okay, so let's figure out what x is. And we'll take this negative 1 and substitute it into one of the two equations. So x plus 2y equals 6. So I'm going to substitute negative 1 where the y is. X plus 2 times negative 1 equals 6. X plus a negative 2, right, equals 6, or x minus 2 equals 6, right? Add 2 to both sides, and we find out that x equals 8. Okay, so now we know 8 is the value of x. Here are two problems for you to use using substitution. And you can graph those if you'd like to check them.
Mark Owen, please come
It's
to the
a
office.
busy announcement day from all I can tell here at school, isn't it? Okay. Sometimes if you solve a system of equation and the result is false, such as you get 3 equals negative 2, then that means there's no solution. If you get a result such that 3 equals 3, then it's an infinite number of solutions. So if you get something that's 3 equals negative 2, there is no solution, right? Very similar to no solution or identity set or infinite number for regular equations. Okay, so if we look at this problem, let's see what happens. We have y equals 2x minus 4 and negative 6x plus 3y equals negative 12. Okay, so let's take this. And, well, you know what? I think what they're suggesting we do is let's put this in slope-intercept form and see what happens. So add 6x to both sides, right? And you get 3y equals 6x minus 12. And if you divide by 3, you get y equals 2x minus 4, right? Well, doesn't that mean that this is exactly the same as our first equation, second equation? Yes, so these are exactly the same. These will graph exactly the same way. So therefore, there's an infinite number of solutions because they're going to graph right on top of each other. Here's two more problems for you to do for guided practice.
Ms. Creighton, your outside duty students are waiting for you at the side door.
Good luck with those problems, and we'll talk about this in class tomorrow.